Hello, everyone. Today we're going to be going over the ice cube problem that I got assigned for the forces between objects explainer video. Go ahead and share this here. All right. The problem states that a contender in a winter sports contest pulls a 45-kilogram cube of ice in the positive horizontal direction with a cable over his shoulders across a frozen lake. Assume the coefficient of static and kinetic friction are 0.1 and 0.03 for kinetic. And for this problem, for my explainer video, I was assigned this part to explain the free body diagram for the cube and then use the free body diagram to write down the net force equations for the cube, but I don't have to solve them. So in this video, I'm not going to be solving any equations. I'm just going to be explaining the force body diagram and the net force equations that you would use to solve it if I was asked to do so. This is a free body diagram for the cube. Before I get into, usually when I do free body diagrams for any problem, I like to start with the normal force and the force of gravity because we know that it always points up in the positive direction. And we know that gravity will always point down in the negative direction. So that's a good place to start so you don't get messed up later on when you have to figure out kinetic friction and the pulling force, pushing force, all those kind of things. So, and then next, we can find that kinetic friction is opposite of the way that the cube is being pulled, because it says up here in the problem, it's being pulled in the positive horizontal direction, which would be right in this case, going to the right. So that means that the force of friction would be in the opposite direction, which in this case is negative to the left. And then the pulling force would be at an angle at 25 degrees. That wasn't given in the actual statement of the problem, but the picture in Expert TA shows that it's being pulled up at an angle, just like this. So when you go to write the net force equations, you want to make sure that for one, you get the right forces in the right axis, as well as figuring out which one's negative and figuring out which one's positive. So to start, you can start with the X direction. So since the pulling force is to the right, which is the positive direction, it'll go right here. And then the force of friction will be minus because it is on the negative, it's pulling to the left, which is negative, and then equals mg. And then for y, now this is where it gets tricky, especially like for this problem. So because this block is being pulled at an angle slightly up at 25 degrees, that means that if you want to find like the normal force or the pulling force, you have to account for that difference that is made by this angle here. Since you're slightly pulling up, that means the normal force is being slightly reduced. And when I work the full problem on Expert TA, that is something I like struggled with most of the time, and something I know a few other of my classmates didn't. We did not understand that either. That you have to take this into account because it's not fully it's not fully on the ground, it's being pulled slightly up at that 25 degrees. So you have to account for that. If I had to go through all the calculations, I would have to account for that when I do so. So that's a big place you can mess up, because if you don't figure out this relationship right from the beginning, then it can mess up all the problem, parts of the problem later on. And then also, just like with these, or with the minus the kinetic friction, the force of gravity right here would also be negative because it is down in the negative direction. And then also you would set it equal to m times g, just like for the horizontal force. So I'll go ahead and stop sharing here. Alrighty, so that is how you go through that problem, and thank you all for watching.